Hello, everybody. How's everybody doing? This is Steve Brumer. I'm a partner at BHIoT Group, and I will be the moderator today for this wonderful panel on the road to 5G for Industrial 4.0. This panel and I are doing a new BrightTALK video conference, so everybody around the world can see us. And we have almost 900 people that are registered for this event, so we're extremely excited about everything that's going on here. So bear with us. We all are showing our best side, so being that we're all on live video, it's pretty amazing. You'll see us grab coffee, grab water, but it's going to be fun. And so the format today for this panel is going to be, each of us are going to have a couple of minutes to introduce ourselves and our company and what we do and how it relates to 5G. Then we're going to go back and forth on a couple of different questions and bantering. For everyone on BrightTALK, there is a question mark button on the right-hand side of your screens that allows you to put in a question for us to be able to answer. All of us have access to it, so someone will answer, and we can go from there. So we're very excited to have all of us on this new format. And so without further ado, I'm going to have each of us introduce each other. So Ricky, why don't you go first?
Thanks, Steve. Yeah, Ricky Watts. I work for Wind River. I'm the VP of the industrial business market in business segment in Wind River. So specific to 5G, obviously, as I mentioned, I look after industrial. Wind River, an embedded software company, has been providing operating systems, real-time operating systems and platforms in the telco environment over 20 years. And that includes, obviously, getting prepared for 5G. So, you know, my responsibility or my role and what I'm looking at is how do we embrace what Wind River has been doing today, and how does that relate to bringing 5G into the industrial domain? There's two different aspects of that, which we're getting today, and I'm looking forward to the conversation. Thanks so much, Steve.
Excellent. Adrian?
Hello, everybody. My name's Adrian Comley. I'm the general manager for what we call Dynamic Network Services at BT. That covers all the software-defined networking products like SD-WAN and virtualized networking products like firewalls or WAN optimization running on x86 devices that then can be also be deployed into an industrial IoT environment.
All right. And Ken?
Hey, Steve, thanks. Ken Hosac with Cradlepoint. I'm our Vice President of IoT Strategy and Business Development. And Cradlepoint years ago pioneered the use of cellular as an enterprise WAN, starting with 3G, going on to 4G LTE, and now 5G and private LTE, private 5G. But our solution consists, it's a combination of cloud-delivered services and on-premise platforms for fixed locations, for vehicles, and IoT machines such as kiosks and digital signage.
Excellent. And everybody, my name is Steve Brumer. I'm a partner at BHIoT Group. We're a worldwide strategy advisory consulting firm in the space. Been doing this 27 years in the machine-to-machine business. Our focus is to help companies monetize, commercialize their IoT products and services on a worldwide basis. So for us, it's about where's the money and how do you make money in this crazy space of IoT. So without further ado, the concept of this panel and this discussion is around figuring out if 5G is driving our future, especially around IoT. And so it's time for all of us, and I know our clients are asking us about it, we're getting asked about it on stage and on sessions, and everybody's talking about 5G and IoT. But we don't know, there's a lot of unknowns and a lot of questions left we need to figure out, and that's what we want to try and address today. And with this panel, we want to try and look at giving you some hints as to how we and our companies and our clients are actually bringing 5G to market, what the expectations are and the requirements, and from a standpoint of looking at big data analytics and everything that's associated with it. So, first question, Ricky, I'm going to go after you. So what areas within the industrial segment does Wind River expect 5G to have a major impact?
Oh, thanks for the question, Steve. So I'll refer back to what Ken talked about. 3G and 4G have already been having an influence in the industrial market segment. 5G is a massive step change in terms of what it potentially offers, not just from a technology perspective, but I'll emphasize from a business-based perspective as well. That's very important. I believe it's going to impact all segments. The ones that I've been focused on at the moment are particularly in the robotics area. And robotics, we could argue, what is a robot? Traditionally, we would argue it's something that builds in a factory, builds a car, whatever. We've all sort of seen those wonderful pictures, but robotics is changing. So I think 5G and mobile going into robotics, extending to robotics, into things like robotic warehousing. I was working with a customer recently on a farming use case where they were looking at introducing mobile, in particular, we're looking at 5G because some of the latency issues around the farming industry. So these are areas, I think all areas are going to be looking at it. I do believe it's very early, but due to the way that the industrial market works, product life cycles are typically quite long. So all segments are going to look at it. They're all starting to consider it. They want to understand how it impacts safety, security, operability, what new services they can bring in. But as I say, for me right now, I'd say I'm really focused around some of the robotics use cases and the extension of robotics around extended robotics to drones and things like that. So that's one area I think is particularly of interest.
So do you think that the robotics part on a manufacturing line will be communicating over 5G?
Well, I would say, they're already communicating. They have fixed connectivity at the moment and systems that control it.
Fixed, but not wireless.
Yeah, and if you look at it, there's different levels of abstraction through ROS. I think things such as cobot is interesting. So collaboration robot, where a typical system from a robotic point of view is a system that does a specific job and repeats it. Cobots are where robots work with people, and if you're adding in cobots, you need to have things like vision, and then you need different types of vision, whether it's the visible spectrum or the invisible spectrum. Those added devices that are connected into the robotics environment need to be connected somehow. So I see 5G as a way to do that from a peripheral point of view and in the robotic environment as well. And you can adapt quite quickly. You can also up the video rate. You can go to high definition. So, that's where the bandwidth and the latency comes in. So again, cobots, some areas, 5G I think will be initially overlaying some things to begin with and then maybe integrating them, because nobody's going to rip out their old system. It's not economically viable to do that. That's not the way industrial works. So it'll be overlaid to begin with, and then obviously you'll see a gradual kind of movement towards what I would hope would be some sort of more interconnected control, and I would say some of these systems that go around that.
Excellent. So Adrian, BT, so give us some examples of where you guys have deployed 5G over 4G, what those applications or what those projects might have looked like.
Yeah, sure. So actually, I'll try and build on the point that Ricky made there about video in a second, but let me just get there, because when I started getting involved with this area, my first question was, well, actually, why do we need 5G? Because you've got kind of 4G and you've got Wi-Fi. But the latency and the reliability of 5G are the reasons why. Because something like Wi-Fi, the latency is going to be up around 140 milliseconds, roughly. It depends on the particular deployment. And most of the industrial IoT applications are going to need to have latency significantly less than that. And you can maybe get that on 4G, but the promise of 5G, maybe getting down to the very, very low milliseconds right at the very edge with edge compute. That's why 5G is quite exciting, because you want to shut off a machine before it damages its production. If you want to have a chemical plant or an oil refinery where you're monitoring the pressure in certain valves, you've got milliseconds to make a decision as to what you want to do. So having that 5G connectivity is really important going forwards. And so just building on what Ricky was saying about visual analytics and video monitoring, we have done some tests with customers on deploying video cameras. So this will look at the output of a machine to say, is the production suitable or not, yes or no? Again, that's a very low latency use case. So you need to have that kind of really fast response time. 4G will handle a high definition camera, but not many of them. In fact, our test in a particular scenario is one camera was all it could handle before it started to degrade the quality. So high def is all you're going to get on 4G. Ultra high definition, which is really what you need to be able to make these kind of detailed analytics work properly, you need 5G for that. And 5G will handle ultra high def, it'll handle increased frame rates, and enable you to get a much better experience out of this, including things like monitoring machines in a production environment. If there's a slight movement on the machine, you want to be able to use video analytics to enhance that and warn somebody about that. You're not going to get the quality and reliability of a 4G connection to be able to do that. You need 5G.
Interesting.
I'd enhance that, Adrian, as well as, if you think of some of the industrial use cases where you've got, like machines that are running, 8,000 revolutions per second, in terms of a process that they're working on. I mean, standard definition is not going to be able to cut it in terms of making those analyses. So, I mean, the machines themselves are working at very, very high speed in terms of the production. And then obviously you've got to recognize a change or a fault or a condition that you're looking for and then react to that. So you're right. Those sub-milliseconds are incredibly important because production can go right unbelievably quickly. And, as I say, sometimes when you look at production, we almost think of it sometimes as a very manual thing, as a thing coming out of a conveyor belt. No, some of the things that we're looking at, the speed of the production or whatever's going on in that process is incredible. So reaction time is absolutely critical, and that's where I agree. 5G latency near to the edge as well, so it's not going right back to a centralized mechanism. Those decisions have to be made very fast. So it makes sense.
Yeah, and so Ken, as we go into the reason you're here, which is you're the router gateway, edge computing device product company. Man, how are we going to get it to the factory floor? I mean, what are you guys looking at? I know you're heavily involved in CPRS and small cells and trying to figure that out with or without your existing router program. So tell us a little bit about how we're going to get 5G to the industrial shop floor in order to get that video feedback and do that analytics.
Yeah, no, it brings me back to the roots of my career. My master's was manufacturing engineering, and I'm very comfortable on a factory floor. I think that one of the interesting things is if you go into a lot of factories today, a lot of the systems there are hardwired with wires because they have not found anything wireless that works. Wi-Fi really doesn't cut it for a lot of these tight processes that you need. And so one of the things that we're seeing first with LTE and coming up with 5G is the ability to create your own private LTE network or private 5G network. And it's not because people want to get free service and bypass the operators. It's actually quite different. It's to address specific applications where Wi-Fi isn't cutting it, and it's not going to replace Wi-Fi, but it's able to, if you can set up a LTE small cell, and again, the CBRS Alliance, which we're actively involved in, is actively developing some of the private LTE capabilities in the US, but being able to set up a private 5G network as easily as you set up a Wi-Fi network, that's going to give you some of the low latency we've been discussing, but also the reliability that you get when you don't have a contention-based protocol, when you have a scheduled protocol. And I think it opens the door for a lot of new applications that really couldn't exist before.
So with edge computing, one of the questions that we already have, which is coming in, thank you very much for keeping the questions coming in. If you employ edge computing, can you get away with 4G?
Well, it depends on the application. One of my favorite quotes was from our friends at Cisco, who said the amount of data being generated at the edge is growing exponentially faster than the ability of the network to process it. And it's not just the 5G part, but it's the backhaul to connect those 5G macro cells and small cells. So edge computing, I think there's a lot of specific applications where you can do processing at the edge and send the metadata up. And it just depends on what kind of application. If you're If you're using artificial intelligence, a lot of times people will bring massive amounts of data up to the cloud, and they'll look, basically to train their machine learning on that, and then they'll send the machine learning algorithms down to the edge and have it process it there. But it really depends on what kind of application, how many data points you're bringing in per second, and what kind of analysis you need to do. But yeah, it's amazing how all of these are converging for. Think about Industry 4.0, the ability to have the edge processing, the ability to have the low latency wireless communication. And I think it's really putting a lot of tools in the kits of folks that are trying to solve a lot of problems on the factory floor.
Steve, there's a question about latency, which might relate back to some of the stats I was referring to. So I'm just picking up on Ken's point there. I'm talking about latency from a machine to an edge computing device within the same factory or campus environment, rather than taking it back to the cloud, which is also important for latency as well. But my comments related to kind of localized, not WAN latency, so LAN latency.
Yep. Thank you for that, Adrian. And I'm going to go back into another question as it related to that, where people are questioning why we need 5G on a manufacturing floor. There's so many different options that are here. Is it going to be cost effective to put 5G on a factory floor in an industrial environment?
It's a good question. I mean, and it's understandable. I mean, one of the things I deal with every day is cost. So, I mean, as Ken mentioned, that traditionally most control systems or most operational OT-based systems are wireline at the moment, or wired. But ultimately, it's about flexibility. It's about what you need to do going forward as well. So as systems tend to adapt. I mean, we're already seeing edge computing come in as an overlay, like AI systems are coming in and adding to the edge. I think 5G, and it goes back to what Adrian said as well, is, what we're trying to do is there are different things that we can add in at the edge of the network. And the ability at some stage to connect what we would call typical control to some of the other systems that are more analytical or back-end based, and closing that loop, I think will require a 5G type of connection because of the latency, because of the bandwidth. But that's really the challenge. 4G was about, maybe I can connect it, I can process it, but it couldn't in any way, shape or form probably be linked to the control system because it's too slow, it's too unreliable. 5G, I think, is going to go beyond that and afford us the ability to be able to connect that thing very reliably at the edge. On a combined edge compute, we've got 5G and applications and services running at the edge, and then you'd be able to close that loop. It goes back to what was mentioned. I can analyze something coming off of a conveyor belt or a production line. I can do that in a very low latency, and I can send a command to stop production, change production, and I can close that loop going forward. And at the moment, it's an unclosed system. It's a manual system. So 5G will be a step to be able to close that. Go back to robotics. You're never going to close robotics unless you can close the time, the latency, and the reliability. Not going to be able to do it.
Perhaps I can just build on that as well, because I think 4G wasn't really designed to upload video. It was designed to download video, and 5G kind of corrects that. And if we think about a manufacturing scenario where you want to use augmented reality to have an expert who's remotely located fix a problem using a local engineer who's wearing they're wearing various headsets to allow the remote experts to be able to see precisely what the local engineer is doing, guide them, perhaps using haptic devices. But the 5G really comes into its own with the latency there, because the human eye will notice any significant delay, and with an augmented reality headset, then you can cause feelings of sickness. So having that low latency is really important. And the question also referred to the kind of the economics of 5G. Yeah. I think there's perhaps lack of information on the kind of overall cost of 5G, but I think in general, if you move from a scenario where you are deploying an expert field engineer traveling around to various manufacturing sites to fix problems, to staying in one location and being able to use virtual devices and augmented reality to access the various machines and talk to a local engineer, their productivity increases significantly, at least by a factor of 2. So I think there's significant cost savings associated with deploying 5G into an IoT environment too.
Well, yeah, we don't have enough. How much information do we have about cost? I mean, we're getting a lot of questions around cost and deployment cost and everything around to that. So we do have to address that.
But if you think one of the things in an industrial environment, one of the most expensive costs is to put those wires in to a device. I mean, I've seen costs that go up to like $160 per foot, you know? I mean, and then if you think I've got to have diverse routing, so, you know, if it's specifically, if it's an actuator like a valve or a pump, I might have 3 sets of wires going in 3 different routes to get to that. You have that then going back up to a DCS system or a control system, PLC, an IO point. The costs are enormous to wire these factories up, you know? So obviously, if it's done and built, you can use it. If you're building something new, and I can reduce by 70% of the amount of wires that I need to install, because I can do that with a reliable 5G connectivity, as you said, with good uplink and downlink. You've got to look at the economics in totality. Yeah, there's a cost to 5G, but there's also a cost to actually build an existing factory in the way that we do it today. And so the economics needs to be looked across what you're trying to achieve. And then I think we'll start to see an interesting shift in the business cases as we go forward.
Yeah, but go ahead, Ken, because I know where you're headed with this. Go ahead, Ken.
Well, I was going to say there's a cost of flexibility too. I mean, when you have processes, even if you build it the way you think it should be built, you've got, you know, manufacturing engineers on a regular basis doing their simulations, and maybe you want to change the process. And if it's wired, you're kind of stuck, or you're repeating that cost. So I think, you know, if it can be wireless, it will be wireless, and that's what we strongly believe. There's so many advantages as long as you can get the characteristics, performance characteristics that you need that are forcing people to go to wires today. But we think that with private networks on factory floors, that you can do that wirelessly with 5G.
So do you think 5G is going to be, from an infrastructure standpoint, a lot more costly than 4G for those people that are doing that on the edge in a factory and in applications?
I think initially, yes. I mean, what we're seeing in the CBRS Alliance, they've hired some consultants to do some analysis of the cost of deploying a private 5G network versus Wi-Fi and versus the wired equivalent, which is distributed antenna systems. And I think, you know, 5G is, as it comes out, just like when 4G came out 10 years ago, the cost of the components, small cells, are going to be a bit higher than what you're seeing with 5G. That'll come down as it gets rolled out. But I think when you do that ROI, that cost analysis versus wires, I don't think there's any question that you're going to be much better off having the wireless factory.
So, Adrian, when you're working with clients from a BT perspective, what are your plans? How do you plan for the future with them? About what's the strategy that you guys offer them in order to make plans to roll out a 5G initiative?
Yeah, so we would look at what the customer is trying to achieve through an IoT solution. So one thing that we see at the moment, if I can just go slightly away from just 5G on its own, is that the case for virtualization, so virtualized network functions running on an x86 device in a factory or at the edge, is still immature. So this was banded as kind of the next big thing. It was ultra hyped. It don't see big global deployments of virtualized network functions anywhere, confirmed by the analysts. What we've started to see, though, is IoT starting to drive the business case. So getting cheaper, more powerful x86 devices, being able to run an IoT app on that in a container, in a VM, having a firewall solution, having segregation of IoT traffic across the LAN for security purposes. That's becoming much more of an economic case that the customer can make. Then you build 5G into that as well, and add in all the benefits we've been talking about in terms of the latency, the reliability, the different types of analytics you can now do much more effectively. So the augmented reality I've talked about wasn't really an option before, it is now. Having the haptic, where you can remotely sense what a local engineer is doing, and have that transmitted across to you in a haptic glove or whatever it might be, that's becoming really important. So I think talking to a customer about what they were trying to achieve today, looking at how we can build in a solution around their IoT requirements, around the edge, using edge compute, and then factoring in the evolution to 5G. So it's really taking customers on that evolution journey.
So, but are they asking questions because of their curiosity and their interest in it, or are they asking you to help with a strategy to deploy planning for their future?
But yeah, the latter, absolutely.
Really?
So, example of one customer who needs to track specialized tooling for particular maintenance activities. If they don't have the right tools in the right place, then they'll miss their SLA for maintaining various pieces of equipment. So they're deploying an IoT solution to better track the tools, tools of all shapes and sizes. You can't do that on a wired IoT type of solution. You need a 5G or 4G solution to better do that. So yeah, absolutely, they're looking for innovation and advice on what's new in the market, what we see elsewhere, and how they can deploy that to ultimately to save money.
Okay. So Ricky, one of the questions was about some of the cloud providers like the AWSs and the Microsofts and the Googles of the world. Have you heard anything from a platform perspective as to what they're doing in the cloud related to 5G?
Most of the cloud providers that I deal with, I mean, what they're interested in is getting things into the cloud. That's where their business model comes from. So, 5G, if it enhances that and allows more connectivity and allows more devices to come in, it gets stuff into the cloud. I mean, I would say if I look at what's going on at the edge of the network, most of the guys that I work with, they have some sort of cloud partnership or cloud relationship, to provide something in the cloud, maybe for analytics and some of the things that we talked about earlier. But specific to 5G, I've not seen anything directly with those players. I've obviously seen some of the companies such as BT and some of the big mobile operators in the US, such as Verizon and AT&T, looking at what they can do in terms of what does 5G enable them to go in there. But the cloud providers, it's about getting stuff to the cloud. Now, that may well change as we go forward and they see there are different opportunities for them. But for us inside of Wind River, it's about, getting the Azure framework or the AWS framework down at the device layer so that there's a connectivity from that device up into the cloud for whatever reason they want. And we've been definitely enabling that and putting that in place. 5G is just going to accelerate that because we're going to be able to connect more things into that environment. So specifically, that's what I think they've been looking at. Now, as I say, maybe that will change over a period of time. Particularly, we talked a bit about edge compute. Well, what is edge compute? It's cloud at the edge. So we're going to see the cloud players move their assets more towards the edge. Then I think things such as 5G and how that gets into it with private edge or private 5G networks, I think that's going to become very interesting. So I think it's early days for those guys at the moment. The business model is about getting compute in the cloud, getting that elastic going, and then monetizing through that. That I think will change over the next 2 to 5 years as they start to see what 5G can potentially offer them in terms of extending it to the edge. We're going to see a shift. We're going to see a shift right the way to the edge of the network. That's where the next wave of connectivity is coming from. And I think we're going to see how the cloud players are going to play in that space and what they're going to look into do and how they're going to partner at the edge as well.
So Ken, one of the questions that came up was Wi-Fi 6 versus 5G, and it will be a complementary technology. How it will combine? Will we use both of them? You saw this week that the Wireless Broadband Alliance and the LoRa Alliance have combined in looking at a possibility of you doing Wi-Fi 6 and LoRa together. What are your thoughts on Wi-Fi 6 and CBRS and 5G? Is it complementary? Is it competitive? What are your thoughts going forward?
Yeah, I think you're going to see both of them coexist, and I think they address different issues. It's interesting. One of our partners in the industry is Ruckus, which is owned by Aris and owned by CommScope, and Ruckus is very well known for what they've been doing in Wi-Fi, but they're also working on the private LTE and the private 5G. And there are certain applications where even with the improvements you're making with Wi-Fi 6, you're still in the same spectrum as the older Wi-Fi standards. You're also in the same spectrum as baby monitors. You're in the, so it's a really crowded spectrum. I think one of the benefits of CBRS, and again, I haven't gotten into the details of what that is, but it's using some spectrum that's owned by the Department of Defense up near the 3.5 gigahertz space. It's basically access controlled, and so there are 15 different channels, 10 megahertz channels. And if you have access, it's under the control of a Spectrum server that's making sure that that if you need to communicate or you have access, that you're going to have that protected access. So it's not just a difference in technology; it's a difference in how the frequency is being used. And unfortunately, in the 2.4 and the 5.0 gigahertz space, it's a very crowded space just because of the nature of it being unlicensed.
It's an interesting thing, and Ken, I'd be interested to get your opinions on this as well. One of the things I kind of look at from a mobile perspective and is often not talked about is the operability aspects to it. It comes with all of the management systems built in, for managing millions of devices at the edge of the network, which when I think of Wi-Fi is more dysfunctional in terms of that. They don't provide a management console. So, I think one of the challenges that a lot of, industrial companies are looking at is like, damn, this is all fantastic, but how am I going to manage it? How am I going to operate it? How am I going to keep security patches up to date on a million devices at the edge of the network? I mean, it's very easy to put a system in. What's much more difficult is to operate it on a day-to-day basis efficiently and keep the plant running, because that's what it's about. That's where their money comes from, keeping the plant running. So I kind of look at, and I came from the mobile world, and they put a huge amount of effort into managing a system with millions of endpoints. So being able to provide that fabric, that connectivity, that security onboarding, into the system, and then managing all of those assets, I think is a real huge benefit that, forget the word 5G in terms of mobile and mobility brings, because they bring all of the management console and all of that capability. So if I'm building a framework and it's about getting devices into the network, I can do that securely. I can do it very fast. I can do it encrypted, and then if I have to do an update or a change, I've got all of the management capability they're built into it. So I think that is something that I know is very attractive to a lot of my customers, because that is one of their big concerns, managing a complex system when these guys are not IT guys. They're not mobile guys. They want something simple that just says, hit the button, make the plant run, And, it's kind of like crayon simple, as we use here in Wind River. Keep it really simple. So, I like that idea that potentially I can leverage that capability from a mobile and bring that to the edge in a private environment. I can take advantage of all of that management capability. I think it's very useful advantage that maybe differentiates itself a little bit from what Wi-Fi potentially offers, just in terms of a pure wireless connectivity.
Got it.
Yeah.
So, Adrian, I'm going to switch gears a little bit. So, security seems to be a very hot topic, and we've had a couple of questions around security. Obviously, with 4G, LTE, CAT-M, NB-IoT, everything that we're talking about from an IoT perspective that's available today, security continues to rear its ugly head in our discussions, and I'm not sure without a standard we have a lot of good answers, but does 5G change any of that, or as it relates to security from the sensor all the way back to the cloud?
Okay, so I think we can look at it in two hops, if you like. Firstly, across the local area network, in which case, my example I talked about earlier, where we're segregating traffic across the LAN, because I think having lots of these sensors, lots of these devices open to the internet creates an opportunity for a hacker to come in, and they can get access to a device that's probably running an out of date instance of Windows. It's not been security patched for years. It's probably got a password of something like 123456. It's not uncommon.
God, I hope not.
Yeah. So really segregating that traffic, taking it to an edge compute device, as we talked about earlier, where you're running the IoT app in a container, you're running a firewall in a VM, you're really treating security very, very seriously. I think 5G just gives you an opportunity to improve that overall security solution. And then taking it back into the cloud, Ricky talked about this earlier. I think we see the predominance of fixed transmission back to the cloud. You've then got an option of IPsec over the internet or MPLS for private networks. We don't see today a kind of an end-to-end 5G solution, but I'm sure that will come over the next few years. It's a matter of time. I don't know if any of the other guys want to comment any further on security at all.
Well, I'll give you my 2 pennies. I spend a lot of time on security. It's fundamental in terms of, I mean, we build from the silicon upward. That's what Wind River does. So you go from the silicon, through the operating system, and the operating system to the middleware, and the middleware to the application. So if we said 5G is an application, what are we doing fundamentally in there? So I think security applies everywhere. It starts from when you build a device, particularly in the safety environment, which, we'll treat separately for now. But, I think 5G is an enhancement to what we need to do already. We know, for example, in the stuff that we're doing today, we will not allow you to install rogue software. We lock it against things such as TPM that comes from the silicon provider, trusted platform. We've got things such as trusted execution environment at the silicon level. So everything that's running, including 5G, including applications, including Wi-Fi, I don't care what runs, what we're doing is we're building inherent security at the platform level to make sure that nothing is enabled to get onto that. Now, does that make it 100% foolproof? We know security is a cat and mouse game. Everybody's always finding something. Yeah. But I can tell you, from our perspective, we start from ground zero, right from the silicon, whether it's IA, whether it's ARM, or whatever technology. We're building on top of that. We're making sure that every single software asset layers on top of that in the right way. We can show what we do from a software perspective and how we apply security, both in our development environment and our test environment. And then I think 5G at a connectivity perspective, in terms of the encryption it offers, some of the things it's doing, I think enhances that. And then I think we look at things like AI to start looking at the running systems. We have an AI system in our platform that's looking at the platform and analyzing what's going on the platform and looking for things that are, hey, this doesn't look quite right. Now, right now, it maybe starts off with, we're not sure, this doesn't look quite right. But as AI gets smarter, those systems can then be linked to control systems. We already, for example, can take an asset, and what we do is we kind of put it in jail. We can take variable compute, look at the application running, say that we think it's not running properly, and we can isolate it in a compute that says, you can only do this task now. We're not allowing you to do anything else. So again, I think security is absolutely fundamental right the way through the edge of it. We're talking industrial plants. We're talking about water processing, power coming out, utilities. These are things that are fundamental to our way of life. Security absolutely has to be at the core of everything that we do. So I think 5G is an enhancement to that. I think it's great, but you've got to start with the basics. What are the platforms? What is the silicon? What is coming through? And again, I think it's part of an ecosystem of security in the way that we do that. So yes, I think it's one thing that adds, but it's part of a much bigger picture in terms of the way that we treat it.
Excellent. So Ken, as you know, the team here at BHIoT Group spends a lot of time educating the world between our webinars, our seminars, and face-to-face events that we do. And education around 5G has been obviously a huge aspect of what we've been doing for the last 6 months or so. So in that realm, and part of what we wanted to try and accomplish today was to educate the hundreds and hundreds of people that are on this call. So one of the things that keeps on coming up is, what the hell is the difference between millimeter wave and sub-6 in a 5G scenario? So if anybody's going to understand that, it's going to be you. So it's your turn to answer that question and educate us, please.
Yeah, well, there's room for both. I think part of the innovation, it's all about the frequency. And so I think sub-6 gigahertz refers to a lot of the frequencies that we're currently using in cellular with 4G, with Wi-Fi, et cetera. But there's been some innovation to start using some of the higher frequencies, like 28 gigahertz in the 30 gigahertz range with this millimeter wave technology. And there are pros and cons. I mean, but the big pro of using millimeter wave is you can carry a lot more data, because when you have the high frequency on that and the shorter wavelengths, you're able to pack a lot more in. The downside is the millimeter waves don't go as far, and so they can be blocked by buildings, etc. That's why when you pull up to a traffic intersection and somebody's in the car next to you, all you hear is the bass coming out of the car. It's not because they're not playing audio, the treble. It's just that the treble, the higher frequencies, are blocked by the structure of the car.
I mean, you hear those basses in Boise, Idaho?
Yeah, oh yeah. Yeah, they're usually people out of state that come here. But so sub-6, I think, is in my view, violates fewer laws of physics. And so for a lot of folks in the industry, I think you're going to see us come out with sub-6 first, because it's easier. It leverages the same antennas. It leverages the same type of systems. And I think whether it's Cradlepoint routers or laptops or automotive, I think you'll start to see that really take off first, because it's easier. It's more like what we've been doing. But the millimeter wave has some real promise in terms of the amount of data that you can get in there. One of the things to be able to support the density required for the towers to support millimeter wave is, you're seeing on the 5G builds, you're seeing the towers, instead of being spaced a mile apart, they're being spaced 500 feet apart. And that's why you're starting to see when 5G is rolling out in the cities, you're seeing it on light poles, power poles, et cetera, traffic intersections, trying to get that density. And part of the real challenge for the operators is that to get that density, you need good backhaul. You need wires in the ground, fiber that can connect all of that. And so I think, the carriers have been planning for this 5G transition for years, and making sure that the backhaul is in the ground, ready to support the density of the towers and the high throughput that you're going to get from 5G. So there's a lot coming together, but it's very exciting to watch. And having seen this transition before on 4G, I think the operators have learned a lot from that previous transition that they're applying to this transition.
In the realm of continuing the education, Adrian, a question came up about support for IPv6 and 5G. Any thoughts around that?
Not really my specific area. I don't know if one of the other guys has got that one covered, but there was also a question on healthcare. I'd be quite happy to answer that one instead, if that's okay. But so in terms of healthcare, let me give you an example, because back in June, BT launched the first remote ultrasound over 5G. So this is where we've got an ambulance going out to treat somebody who's injured. They can put some, they can use ultrasound. They've got a paramedic on site. They're wearing a haptic glove. They send back the feedback over 5G to a consultant in the hospital or their house, wherever they're located, who can then remotely tell the paramedic how to move that ultrasound device over the patient. They can then make a call as to whether there's not a problem, they don't need to come to hospital, or get them to hospital straight away. So that's just one example of how 5G can help in the medical profession. And it ties back into what I was talking about earlier about augmented reality and having an expert remotely advise a local engineer, which really increases their productivity overall. And then the healthcare industry, it's about saving costs and saving lives and keeping people alive for longer.
And I might just add to that,
Ricky, on that note, what other industrial areas do you, in vertical markets, do you see as being a huge opportunity for 5G?
I'll add a few bits. I just before we did, I just want to look back to something Ken said, and when he was talking about millimeter wave versus sub 6. One of the concerns has been from a lot of the industrial guys is, what if someone sticks a wideband frequency jammer, next to a plant, and obviously, to exactly the point that Ken made out, the lower the frequency range, the easier it is potentially to create a jamming signal. So one of the things that I talk about to a lot of customers is that the millimeter wave, because basically your door is like a 10-foot brick wall at the 28 gigahertz range. That means if I'm in a local environment, let's say I'm in a small plant room that's running a pump, beg your pardon, and it's connecting some devices, it's pretty localized in that small environment through maybe a small cell deployment. And the idea of being able to jam that signal from external to the plant, I mean, you basically probably have to have something the size of half of Texas to actually generate a type of signal that could actually penetrate those frequencies at that millimeter wave frequency. So I kind of wanted just to mention that because I think it's important. Millimeter wave is great for all of the things that Ken said, increased bandwidth because of the frequencies you're using, but also actually has some very interesting impacts in terms of security and connectivity as well, because it's very localized and it's very isolated. So that means that, signals are not going to interfere with each other. They're very localized. And of course, they can be very secure. So I just wanted to add that it's an often overlooked consideration, but, the guys I talk to, big worry for them. If you jam something and it's an important device, again, it's all about downtime. You can't take the plant out of service. They got to run. So, and then following up to your second question, there's some interesting use cases in environments that we don't necessarily think about, and oil and gas is an interesting one in the upstream, of oil and gas, which is where they extract out of the ground or out of wherever they're taking it from, and oil rigs and things like that, so providing a lot of extra connectivity in those remote environments using, mobile, using the benefits of 5G, potentially in that environment would be very, very interesting. Again, it's very localized. There's a huge amount of cost to building those types of plants. So you might be able to make them a lot more efficient. You can make them a lot more connected. So there's an interesting environment, again, from a use case perspective that you can add in. The other one that I'd spend a lot of time on is transportation. Now, we haven't sort of talked about it here, which is the autonomous vehicle, and how does an autonomous vehicles are an interesting use case in itself. How is that going to connect back to cloud or edge compute? And I know there are different types of technologies that are being evaluated, but 5G and the latency required to make some interesting decisions around autonomous driving is another very interesting area. And I think you're going to see a lot of activity, as we're already starting to see in autonomous driving. You add in 5G, and I look at it from how are you going to connect a car to whatever it's going to talk to? So, and some, these roadside units, RSUs as they're called, that could be a 5G connectivity. And then, of course, you might have intelligence.
I think it has to be in order for anything to work.
Yeah, well, there are some alternate options out there as well that the industry's been looking at, but I think 5G is going to dominate that because the economics come in. I mean, the economics of 5G on a global basis means, like Ken mentioned earlier, with the small cell, yeah, they may be $1,000 today or whatever the number is, but with the economics of any technology as it proliferates, the cost is going to come down. So that means that from a access technology, if you're connecting 17 million cars on the road, in an autonomous way to the edge, 5G economics are going to come into play as well. So it's an economics business as well as a technology thing. So, everything that we do in our life today, believe me, is going to get impacted by 5G. much more than probably people anticipate. And I think it's just going to proliferate everywhere. 5G is a game changer in terms of the mobile wireless industry and what we would call industry IoT in terms of what it's going to offer. We're going to see use cases that I don't think any of us have even dreamed of in the next few years. Believe me.
You mean things that we couldn't do on 2G? Is that what you're saying?
Yeah. Like, hello, are you still there?
Hey, listen, 2 cans in a string worked really well. So
We have dreams.
Yeah, exactly. So Ken, you're seeing a lot of different types of applications. Those obviously the ones that were just mentioned are the big ones. Any other ones that you see, or like from a low-hanging fruit opportunity for 5G over the next couple of years? I mean, smart cities is a huge one that's happening over in Asia and India. Smart buildings. I mean, we're talking about outside versus inside. A lot of different use cases, but what are you seeing that's like really exciting that you think that can be a good money-making opportunity?
Yeah, we all like to put things into simple categories, and I think I'll take 2 slices at it. I think there are certain applications that with 5G you can make those applications better, but then there are other applications that could not fundamentally exist without the capabilities of 5G. I mean, we saw that in 4G, we saw that in 3G. Yeah. But in terms of grouping the applications, I think there's the group of applications that fall into the category of mobile broadband. There's another category, which is the massive scale of IoT devices. And then these specific applications for low latency that you really couldn't do before. And I think what often gets ignored is that mobile broadband. And I think here in the U.S., one of my favorite quotes was from Lowell McAdams at Verizon, and they were rolling out fiber to the curb in residential areas, and they stopped that program. And he basically said their number one use case for 5G is residential internet. So we're talking about 3 kids in a basement watching separate screens of Netflix at a price point that is attractive to consumers. That alone is a game changer for enterprise and industry. And I think even if you do have a private 5G network in a factory floor addressing some of those low latency and some of those IoT requirements, you may still backhaul that factory over public 5G to one of the operators because it's still better than wires. And in fact, you may pick 2 operators and use SD-WAN and have an all wireless backhaul. So that mobile broadband, the ability to have high throughput, and because of the density of the towers, because all the work that the operators have done to put fiber in the ground to connect it, I think you're going to start to see data usage caps start to go by the wayside. And instead of saying I'm limited to 5 gigabytes a month, which I can blow through in 5G within seconds, maybe I'm paying for bandwidth tiers. So I think those applications, I can go through use cases for a couple hours, but you talk about smart city. I mean, we're working here in the U.S., public safety. If you think about a police car, you have body-worn cameras, you have dash cameras, a lot of video content. You have IoT sensors. If you pull the shotgun out of the rack in a police car, that's a big deal. They send an alert to the operations center. They come down and look in the cameras. They're not pushing that video 24/7 up to the operations center. They're only doing it in an emergency or if there's a reason to do it because it's too expensive. So I think as 5G starts to roll out, offering the ability to have high throughput and starting to maybe take some of the pressure off of data caps because of the way the networks are designed, I think you're going to start to see people use that mobile broadband area a lot differently than they have in the past.
Yeah, I would tend to agree with that. So we've got about 5-6 minutes left. One of the things that I wanted to ask each of you to give a closing statement a little bit about where you see the road to 5G going. I'm more interested in time frames and the makeup of the audience. It could be from vendors to corporate enterprise users to people within the infrastructure and obviously carriers. So give us a little bit of your thoughts on what the road to 5G looks like for us. Is it today? Is it 3 years, 5 years from now? What would you do? So Adrian, why don't you start off?
Yeah, okay. So I think where are we with 5G? Well, it's in the UK anyway. It's being rolled out now. So to various cities. I think we've got 10 cities in 2019. Further rollouts across 2020. So I think for me the kind of rollout phase is over the next few years. When we get to about 2022, we're going to see kind of a mass rollout of 5G. New spectrum, new chipset capabilities, and convergence of the network. So fixed and 5G becoming much more common as a deployment for a multinational corporation, both in terms of their IoT requirements, but also their WAN requirements as well. And then from about, 2023 onwards, you're going to get the much more kind of ultra low latency use cases will start to become more widespread. We're going to see network slicing. We haven't really mentioned that too much, but cutting the network up into specific applications, that's going to become more widespread as well. So, I mean, that's a very, very quick overview as to where I see this going in the next few years.
Excellent. Ricky?
So, similar to what Adrian said, so the time is now. I come from a world where we have product life cycles of 15 to 20 years. We build appliances, they're purpose-built machines top to bottom. There's a GUI, there's what the thing does and the control system. So if you're going to start looking at what do you need to do to embrace these new things, they are going to take years for companies to start to build products and build solutions around in the area that I come in, the OT environment. So you've got to start that knowledge base now, and you've got to start building that knowledge. I'm not expecting to see, a massive wave of new products in the next 6 to 12 months, but you've got to start the process now. So you've got to get your experience up. You've got to get your understanding up. You've got to understand what it's going to do in terms of your business models. We talked network slicing. You're right, we didn't talk about that, Adrian. So there's a great opportunity to change business models. Is a company going to become changing to a software company, an application or services company? All things are going to change. So my message would be, I don't expect a revolution. It's an evolution. Start the learning process now. Start to understand what it means for you and your company. And then I think as you start to adopt that approach, you'll adopt your strategy. You'll adopt new partners, new go-to-market approaches. Are you going to be working with a carrier? Are you going to be working with a telco provider? Are you going to be doing something different? So I think the time is now. Start understanding it. Start to factor it into your business. And then I think in terms of when are we going to see 5G start to roll out in the field? In certain use cases, I think probably in the next 24 months, we'll see some early things coming out. And then I think as we start to go beyond that, we'll start to see it accelerate, as I mentioned. It's going to change everything that we do. And I really mean that passionately. It's going to change everything. If you don't start now, you're going to be late to the party and you might not even get into the party. So, that's my current thinking.
All right, Ken, got about a minute.
Yeah, I think we run a Path to 5G consultancy program here because the Path to 5G, it's different for every company. I'll give you an example. If you're State Farm and you have 18,000 locations, as the name farm implies, you're in a lot of rural areas. I think 5G, you're going to see them light up the NFL cities first in the US. And it's going to take a couple years to roll out. And that's going to be very different than if you're a smart city in a major metro area where you can take advantage of this. So it really depends on what is your application, how do you plan to use 5G, and we'll work with that around the timing of when the rollouts are happening. Support for IoT is coming in later, et cetera. So
excellent.
This is a quick answer.
There you go. Well, gentlemen, thank you so much for your time today. I think this discussion helped a lot of people that were on the call and on the video to actually learn something new from us, which I agree, Adrian, education is critical right now. The questions that are coming out, Ricky, the same thing. People trying to figure out, is it now? Do I wait? Do I wait till Apple has a 5G phone in order to do anything? There's so many of these educational aspects that are having to be addressed right now. So we are all part of the ecosystem. It's our responsibility to educate vendors and people and that's definitely something we do at BHIoT Group on a regular basis. So, well, thank you so much, gentlemen, for your time. Audience, thank you for the hundreds and hundreds of people that have been on the call for the last hour. We appreciate your time. We'll see you at Mobile World Congress in a couple of weeks, and thank you very much.
Thanks, everybody.
Thank you.
Bye-bye. See you. Have a great day.
And you, everybody.